Hi everyone. Here's our look at dilution. Dilution is probably a word that you're familiar with, but here's a more official definition. It's the addition of a solvent to a solution to decrease the concentration. It's adding water to a solution to make the concentration go down. We have a formula for it. It's C1V1 equals C2V2. This is the initial concentration multiplied by the initial volume. That's equal to the final concentration multiplied by the final volume. Here, the units must match. The two concentrations will have to be the same units. They could both be percent, they could both be parts per million, or most commonly, they're both going to be moles per liter. The same for the two volumes, they must match. They could both be in liters or both be in milliliters. In addition, to help with our interpretation, because of what the definition has to say, we start with a solution and we do something to it to make the concentration go down. So by definition, the initial concentration is always going to be larger than the final concentration. And because we're adding solvent, we're adding water, it's also true by definition that the initial volume must be less than the final volume. This is not such a complicated formula to manipulate around. It's very reminiscent of Boyle's law. However, here are the four manipulations. We're never going to use this formula exactly as it appears. We're always going to have to manipulate it into one of these four versions. Something else just to keep track of as we're reading questions. The initial concentration, that's sometimes referred to as the stock solution. In a lab, chemicals are often stored at high concentrations as stock. And then when we're going to use them, we dilute them down before we do a lab. One also big heads up, there's a difference between the final volume versus the volume added. We need to pay attention to that. It's not going to happen so often that we're asked for the volume added. However, there's a difference there. The final volume is exactly where we end up. We're going to see that a lot. But the volume added, that's the change in volume. The final volume, subtract the initial volume. How much water did we actually add? Here's a couple of example problems. Determine the volume of 3.50 mole per liter solution required to prepare 100 milliliters of 0.600 mole per liter solution. Now, we see a couple of things here that can really help our interpretation. We have these two concentrations, and because it's dilution, by definition, C1 has to be larger than C2. If I have those two concentrations, then the bigger one must be the initial concentration, C1. And then this one over here is C2. We also have this sort of standard way of expressing things, volume of concentration, to link those two together. So if that's C2, this must be V2. And that means we're determine the volume. We're looking for V1 question mark. Another thing to look for is this 2 right here. We're going to have a volume of that solution, and then we're going to use it to prepare. There's a chronology here. There's a before and after. It's not always the first part of the sentence that's the before, but here it is. Before, to, after. Notice that the chemical itself is left ambiguous. There's nothing here about moles or mass or the specific chemical itself. So sometimes we might see it's this particular acid or this base or this solution. However, there's going to be times like this question where that's left a little bit ambiguous, and that's okay. So I've worked on my interpretation. I've done what I needed to do to wrap my head around the question. I'm looking for V1. Here's the manipulation. V1, it's C2 times V2 divided by C1. I'm going to write that down again. V1, C2, V2 over C1. Before I even start, I should also have this expectation. Because I'm looking for V1, by definition, V1 must be smaller than V2. So I'm not quite sure what my answer is going to be, but I do have this idea before I even start that my answer must be less than 100. If somehow I get an answer larger than 100, then I might think, oh, did I manipulate the formula incorrectly? Did I put some numbers in the wrong spot? Did I push a wrong button on my calculator? C2 times V2 over C1. This is, the C2 was 0.6, 0.600 moles per liter. V2 was 100 milliliters. This is over C1 3.50 moles per liter. When I look at the algebra here, I can see that the moles per liter are going to cancel, and that leaves my answer in milliliters, or the units are going to match. Because my first volume was in milliliters, this answer is likewise going to come out as milliliters, and that's okay. Get my calculator, here we go. 0.6 times 100 divided by 3.5. I get the answer, 17.1428571. Big, long, raw answer, which you need to round off to, I look at my question, 3 significant digits, fairly typical. This is 17.1. We already talked about the units milliliters. I had the expectation that the answer would work out to be less than 100, and sure enough it did. Here's a second example. If 15.0 milliliters of 1.35 mole per liter solution is diluted to a concentration of 0.200 moles per liter, what will be the final volume? Again, you might feel comfortable enough to dive right in. You might want to slow down and get some units into, some labels, into the question as we work on our interpretation. Again, I can see 2 concentrations, 1.35 and 0.2. Look at those units, moles per liter. By definition, C1 must be larger than C2. So the bigger concentration has to be C1, and this one down here is C2. Look at that volume of concentration. They're grammatically linked. They're really close to each other in the question. If that's C1, then this one here must be V1. Plus, what will be the final volume? The final volume, that must be V2 that we're looking for. We've taken our time to interpret the question, get some labels in there. Before I even start, I have this expectation. Is my answer going to be larger or smaller than 15? By definition, the final volume, V2, has to be larger than V1. We added water to it. That's what dilution is. So I have this expectation. I'm not quite sure what my answer is going to be, but I do know it has to be bigger than 15. I move on to the calculation. I'm looking for V2. Here's the main formula, manipulate it around, V2 C1 times V1 over C2. I'm going to recopy that down. Just helps me feel organized to recopy the formula. Now I start to substitute my values. C1, 1.35 moles per liter. V1, 15.0 milliliters. Over C2, 0.2. When I look at the units, I see that the moles per liter are going to cancel. It's going to give me an answer in milliliters, which is what I expect because the units are going to match. I type away. 1.35 times 15 divided by 0.2. I get 101.25. The raw answer that comes out on my calculator screen, there it is. I need to apply my significant digits and get some units in here. The three numbers in the question had three significant digits, so I round this off appropriately. Rounds down to 101. And again, this was the volume that we had in milliliters. Dilution, it's a really workable kind of idea. It has some really strict things built into the definition that can help us with our interpretation. The manipulation of the formula is pretty okay. Watch out for mentions of the stock solution. That really applies to the initial concentration, sometimes even the initial volume if we're talking about the stock solution. We didn't see it in our couple examples, but big heads up, there's a significant difference between final volume versus volume added. Here in this question, we found the final volume of 101, but the initial volume was 15, so how much did we add? 86. So watch out for that one. Take your time with the manipulations. The units have to match. And don't forget those significant digits and units. I hope that helps.